Okay, so we have two more examples about estimating square roots. This one we're going to be practicing estimating to the nearest tenth. Our first step is to always try to figure out what our two whole numbers that we're closest to are. And so, in looking at my 33, if I'm looking at, sorry, I've got a cat walking across my table. If I'm looking at my list of square roots, I notice that 33 falls between my 5 squared, which is 25, and my 6 squared, which is 36. And so 33 falls somewhere in between 25 and 36. So that means my two consecutive numbers are 5 and 6. From there, I like to ask myself, which one am I closer to? Am I closer to the 5 or to the 6? So 5 was square root of 25, and 6 is the square root of 36. So if you're like, well, I don't know looking at it, Mrs. Cartwright, how do I know which one I'm closer to? Do some subtraction. 33 minus 25 gives me 8. And 36, that doesn't really look like a 3, minus 33 gives me 3. And so I'm closer to the 36, which means I am closer to the 6. Now, what that means is when we're going from 5 to 6, I know that 5.5 is halfway, and so I am between 5.5 and 6. So that helps me to where I'm not starting all the way at 5.1 and having to work all the way up and square everything. I'm just going to go ahead and start with 5.5, 5.6, 5.7, 5.8, possibly 5.9, depending on how close we get. We do know that 6.0 squared is 36. Now, because we are only 3 away from 36, I'm going to actually start in this like 5.6, 5.7 area. Just because I know that, 3 is not really in the middle of these numbers. So I'm going to start by doing 5.6 times 5.6. We get 36. 30 plus 3 is 33. And then we do the next line. 5 times 6 is 30. 5 times 5 is 25, 26, 27, 28. And so now I'm going to add. We get 6, 3, 11, and then 3. So here I am. 5.6 is 31.36. So not bad, but I'm not past 33 or, too terribly close to 33. So now I'm going to do 5.7. And 5.7 squared, we get 49, 35, 36, 37, 38, 39. Then 5 times 7 is 35. 5 times, and that makes that a 3. 5 times 5 is 25, 26, 27, 28. And so 9, 14, 8, 9, 10, 11, 12, and 3. 2 decimal places, so 2 decimal places in my answer. And I'm getting closer. I'm at 32.49. So I am almost there. My guess is 5.8 is going to be bigger than 5 or than our 33 that we're looking for. So we have 5.8 times 5.8. 8 times 8 is 64. 8 times 5 is 40, plus 6 is 46. 0. 5 times 8 is 40. 5 times 5 is 25, 26, 27, 28, 29. So then we have 4, 6, 9 plus 4 is 13. And here we have 33.64. At this point, I can stop my table. Again, you don't need to keep doing squaring numbers if you already have one number below and one number above your 36, and you want the ones closest consecutive up on the top row, but where our 33 fits between. And so that is between 5.7 and 5.8. And now I have to decide, well, which one do I round to? And so we're going to take our 33 and we're going to subtract the 32.49 because I want to find the distance from my number to 5.7 squared. So 33, I'm going to add those zeros there. I'm going to borrow from the 3 and make that a 2. Makes this a 10, but then I have to borrow to make this one a 10. 10 minus 9 is 1. 9 minus 4 is 5. And the rest is 0. So 32.49 is 51 away. Then we're going to do 33.64 minus 33.00. And we are left with 0.64. And so barely the one that is closer is our 32.49, which makes our answer approximately. And I do these approximately's because we are very much estimating when we are, especially with a number that never ends, when we round this to the nearest tenth. And so we're at approximately 5.7 as the answer to the square root of 33. All right, last problem. This one is more real world. So we're in our booth. There's a square table. The table has an area of 26 feet long. So we know we're working with a square. Oh, sorry, I misplaced my little red dot. We're working with a square, so I know that that area is side squared. I know my area is 26 feet, and we want to hang a table skirt along the edge of the table. So approximately how long does the skirt be to wrap around the perimeter of the table? So perimeter is going to be 4 times our side length. So first we have to find a side length. So I know my area is 26 feet. That equals side squared. The inverse operation to squaring something is to square root it. And so I'm working with the fact that the side is equal to the square root of 26. I'm estimating to the nearest whole number. So really I need to find the 2 numbers that the square root of 26 falls between, which would be 25 and 36, right? Because 26 is right here. Excuse me. And so since 26 is closest to 25, I'm going to think, okay, well, what's the square root of 25? And that is 5. So our side length here is going to be approximately 5. From there, I now just plug that into my perimeter. Perimeter equals 4 times our side length, which is 5. And so our perimeter is going to be 20 feet. And so I need approximately 20 feet to wrap the skirt, to wrap the table skirt around the table. And so this is how square roots can help us, because I didn't need the actual square root of 26. I've got enough that I should be able to reach it. If it really bothered me, I could add a foot just for the sake of, making sure that I round up instead of down and end up being short. So that is the gist. And really my goal is really, can you figure out what 2 whole numbers you're between, and then ask yourself which one of those you're closer to. If you need help with the tables, holler. I am here to help you. It is a lot. It's a lot of just tedious work. It's the way they used to have to do square roots before they had the lovely calculators to do it for them. So, until next time, 8th graders. Deuces.